What we are seeing here is a GPS satellite prototype. And the module which is being focused is the advanced intelligent remote positioner, which is basically used to snip the housekeeping activities inside a satellite, which will be explained in detail during this demo, which I'll be taking across. And this basically forms your base station, central command. And the software which is loaded basically controls the switching, sequential and arbitrary switching of your satellites from east to west, in the east to west axis. And the unit which is shown here forms the master central control. Actually, when a satellite is in an inclined position, the footprint of your commercial satellites will be very low. That means the area of coverage might be faded out, or there is a chance for the region area of coverage might get cut out. So this unit basically finds out the actual drift in the satellite, finds out what is the cause, and it will relay that information to the master control center. So this is a small prototype which is designed for this purpose. I'm going to explain you regarding the hydrogen thrusters and why this hardware unit has been designed and its real-time application. I'm going to give a demo in a couple of seconds. Maybe 1 second. Actually, in this module we have incorporated two types of control. One is AGC controlled and another one is program controlled. In low signal situations, when there is any change in AGC voltage, it would result in degraded signal quality. And this module forms the program controlled one. The calculations are based on the program data entered into the controller. The functions of this tracking controller has been integrated in our general purpose antenna controller. So if any problem in one transponder, the unit will automatically switch on to the next transponder, and our GPS receiver will tell from which transponder and from which satellite it is basically receiving the info. To give a more brief about station keeping. Actually, before telling something about station keeping, excuse me, I like to tell something about small intro about communication satellites. Actually, the communication satellites are fitted with small rockets called thrusters. Let me take a closer look and I'll show it to you. These are the thrusters. This one, here, these two. We have at the back these two, and these thrusters are situated on all the 4 sides of the satellite. So basically, see, once we get a command from the ground station, the thruster is first fired. So during firing, it ejects a gas like an air which escapes from a balloon. The ejected gas produces the force. And makes the satellite to traverse in its orbit. It does some vernier corrections within the tolerance levels of the satellite. The ground station precisely controls all parameters involved in firing. What is this unit? The position of each thruster relative to the satellite, the timing, the duration of each fire, and the pressure of the ejected propellant. And all these things will be controlled properly in order to maintain the satellite in the proper position and altitude for years. This concept is called as station keeping. This is very much developed. This is very much required. Why we developed this small prototype was basically to find out when a satellite loses its area of coverage, that is the footprint. So we will basically move to another satellite. Normally that command will be given from a central station. So in the meantime, before that information gets relayed to our receivers, we will get an update on our receivers. It's only an update, we won't be in a position to control. But what we are showing is an actual control. Okay, now let's see in action. So first I'm going to remotely. As you can see, this motor basically powers the hydrogen thruster. Speed, then reverse direction. So these hydrogen thruster valves, MOVs, motorized operated valves, will be fired in a diagonal directions. So it gives drift and makes that satellite to move along. And what you see is basically a stalling operation. It doesn't rotate in the forward direction, it doesn't rotate in the reverse direction. Basically it stalls, it blocks once enough thrust is not built. The moment enough thrust is built, then from the central command station, this is basically a central command station, we will be instructing the unit present inside the satellite to traverse about. Once it reaches the desired tolerance and the right altitude and the right location, a lock command will be sent from the base station to the satellite. This is called emergency locking. This is I'm going to increment in terms of positive steps. So these two motors depict MOV firing pin. These are the status LEDs that show the firing levels. Once it reaches the orbit, it goes. And when we observe carefully the forward direction, one indication being displayed, increases. The thruster has been fired to the full extent. It's doing a course correction, now a fine correction. It has reached in the right orbit, so emergency stop.